வணக்கம் மாணவர்களே. இன்னைக்கு நம்ம ஸ்டாண்டர்ட் 12th ஃபிசிக்ஸில் யூனிட் 10 கம்யூனிகேஷன் சிஸ்டம்ஸ் இந்த சாப்டர் பார்க்க போகிறோம். தமிழில் உங்களுக்கு தெரியும் தகவல் தொடர்பு அமைப்புகள். ஸோ இந்த சாப்டரில் நம்ம பார்க்க போகிறோம் இன்றைக்கி. ஸோ கம்யூனிகேஷன் சிஸ்டம்ஸ் 1 and 3 mark and 5 mark question and answers you are going to see in this session. ஸோ ஃபஸ்ட் எடுத்த உடனே மல்டிபிள் சாய்ஸ் கொஸ்டின்ஸ் பார்க்கலாம். First question வந்து the output transducer of the communicative system converts the radio signal into dash. So options என்ன கொடுத்துருக்காங்கன்னு பார்த்தோம்னா A sound, B mechanical energy, C kinetic energy, D none of the above. So இதோட ஆன்சர் என்ன பார்த்தோம்னா ஆன்சர் இஸ் A sound. அடுத்த கேள்விக்கு போகலாம். The signal is affected by noise in a communicative system dash. Options are option A are the transmitter, option B are the modulator, option C in the channel, option D at the receiver. இதோட ஆன்சர் என்னன்னா ஆன்சர் இஸ் C in the channel. ஸோ இப்போ அடுத்த கேள்விக்கு போகலாம். கொஸ்டின் நம்பர் 3. The variation of frequency of carrier wave with respect to the amplitude of the modulating signal is called dash. இதோட options A amplitude modulation, B frequency modulation, C phase modulation, D pulse width modulation. இதோட answer B frequency modulation. அடுத்த question போலாம். The internationally accepted frequency deviation for the purpose of FM broadcast. FM broadcastனா frequency modulation. அது லாஸ்ட் கிளாஸில் பார்ப்பீங்க. ஸோ அதோட ஃப்ரீக்வன்சி என்னன்னு பார்த்தோம்னா accepted frequency options are given. A 75 kilohertz, B 68 kilohertz, C 80 kilohertz, D 70 kilohertz. Option A 75 kilohertz. Question number 5. The frequency range of 3 megahertz to 30 megahertz is used for dash. எந்த ப்ராப்பகேஷனில் இந்த ஃப்ரீக்வன்சி ரேஞ்ச் யூஸ் பண்ணுறோம் அதுதான் கொஸ்டின். அதோட ஆப்ஷன்ஸ் A கிரவுண்ட் வேவ் ப்ராப்பகேஷன், B ஸ்பேஸ் வேவ் ப்ராப்பகேஷன், C ஸ்கை வேவ் ப்ராப்பகேஷன், D சேட்டிலைட் கம்யூனிகேஷன். ஆப்ஷன் C ஸ்கை வேவ் ப்ராப்பகேஷன். அடுத்த கொஸ்டின் போகலாம். கொஸ்டின் நம்பர் 6. Which remains constant in amplitude modulation? Option A phase of the carrier signal, option B frequency of the carrier signal, option C both A and B, option D none of the above. இது லாஸ்ட் கிளாஸில் பார்த்தோம். ஆம்ப்ளிடியூட் மாடுலேஷனில் நம்ம ஃபேஸ் அண்ட் ஃப்ரீக்வன்சி கான்ஸ்டண்ட்டாக வைப்போம். ஸோ த ஆன்சர் இஸ் ஆப்ஷன் C both A and B. Shall we go to next 7th question? Yeah. So which of the following is an input transducer? A amplifier, B loudspeaker, C microphone, D all the above. இதோட ஆப்ஷன் ஆன்சர் இஸ் C microphone. Question number 8. The height of the antenna must be a multiple of A lambda by 4, B lambda by 2, C lambda, D lambda by 8. இதோட ப்ராப்ளம் கூட நம்ம லாஸ்ட் கிளாஸில் பார்த்தோம். So the height of the antenna is the multiple of lambda by 4. So answer is A lambda by 4. So question number 9. Which of the following based on the principle of radio echoes? So radio echoes உங்களுக்கு தெரியும். So அதோட ஆப்ஷன் வந்து A sonar, B television, C radar, D none of the above. So the answer is option C radar. Question number 10. Which of the following is used in optical fiber? ஸோ ஆப்டிக்கல் ஃபைபர் பார்த்து நம்ம இந்த லெசனில் பார்க்க போகிறோம். ஸோ ஆன்சர்ஸ் ஆர் A டோட்டல் இன்டர்னல் ரிஃப்ளெக்ஷன், B ரிஃப்ராக்ஷன், C டிஃப்யூஷன், D ஸ்கேட்ரிங். ஸோ இதோட ஆன்சர் A டோட்டல் இன்டர்னல் ரிஃப்ளெக்ஷன். ஸோ இப்போ வந்து 3 மார்க் பார்க்கலாம். 1 மார்க்கு நம்ம புக் பேக்கு பார்த்தோம், ப்ளஸ் எக்ஸ்ட்ரா இன்சைட் த புக் ஆல்சோ வி ஹவ் சீன், அண்ட் தெர் ஆர் மெனி 1 mark that I will tell you how to prepare in the last session. So question number 1 3 markல what are the different modes of propagation? So எந்தெந்த மோடில் நம்ம ப்ராப்பகேஷன் ஆஃப் யூஸ் பண்ணுறோன்னா கிரவுண்ட் வேவ் ப்ராப்பகேஷன், or surface wave propagation. இதோட bracketல nearly 2 kHz to 2 MHz பார்க்குறீங்க. So, இந்த frequency you have to remember because 1 markல this frequency question வரலாம். Next, second propagation is skywave propagation or ionospheric propagation. Nearly 3 MHz to 30 MHz. இதோட question கூட நீங்கள் choose-ல பார்த்தீங்க. So, space wave propagation, the third one, that is in the range of frequency nearly 30 MHz to 400 GHz. அடுத்த question, second question போலாம். What is ground wave propagation? What are ground wave? இது டீட்டெயில்டாக நம்ம படிக்க போகிறோம் 5 மார்க்கில். இப்போ இது 3 மார்க்கில் கேட்டால் இந்த மாதிரி ஆன்சர் பண்ணணும். If the electromagnetic waves transmitted by the transmitter glide over the surface of the earth to reach the receiver, then the propagation is called ground wave propagation. The corresponding waves are called ground waves, or another name is surface wave. Question number 3. Where do we use ground wave propagation? எங்கெல்லாம் யூஸ் பண்ணுறோம்? Ground wave propagation is used in local broadcasting, radio navigation, for ship-to-ship communication or ship-to-shore communication and mobile communication. அடுத்த question. What are sky waves? What is skywave propagation? The mode of propagation in which electromagnetic waves radiated from an antenna directed upwards at large angles gets reflected by the ionosphere back to earth is called skywave propagation or ionospheric propagation. The corresponding waves are called sky waves. Next question. Define skip distance. இது ரொம்ப important question. இது frequently asked question. So, you should learn this definition. So, what is skip distance? பார்த்தோன்னா, it is the shortest distance between the transmitter and the point of reception of the sky wave along the surface is called as the skip distance. Sixth question. Define skip zone. Skip distance skip zone மாற்றி கேட்குறாங்க. ஸோ உங்களுக்கு இந்த question also important. So what is skip zone? If we see the zone where there is no reception of electromagnetic waves, neither ground wave or sky wave, called as skip zone or skip area. Question number 7. What is space wave communication? What are space waves? The process of sending and receiving information signal through space is called space wave communication. Second point பார்த்தோம்னா, the electromagnetic waves are very high frequencies, about 30 megahertz, are called as space waves. Next question. Where do we use space wave propagation? The communication systems like television telecast, satellite communication and radar are based on space wave propagation. இப்போ நீங்கள் இந்த கிளாஸ் பார்க்குறது கூட டெலிவிஷன் டெலிகாஸ்ட். ஸோ தட் for this what mode of propagation is used means space wave propagation. Question number 9. On what factor range or distance of coverage of propagation depend? Write the formula. So range means distance. So the distance depends on what factor and what is the formula to calculate, we are going to see. So the range or distance d of coverage of propagation depends on height of the antenna h, and that equation in order to calculate this distance is given as d is equal to root of 2rh. So where h is the height of the antenna, you know, and what is r? R is the radius of the earth. This radius of the earth value is, you know it is 6400 kilometer. அடுத்த கொஸ்டின் போகலாம். ஸோ லாஸ்ட் கிளாஸில் நீங்கள் பார்த்தீங்க ஆண்டனா ஹைட் எப்படி கால்குலேட் பண்ணுறது அப்படின்னு. நவ் another problem based on distance that we are going to see in this class. So what is this question? Let us see. A transmitting antenna has a height of 40 meter and the height of the receiving antenna is 30 meter. See, antenna height is 40 meter and the transmitting antenna. So we have got two antennas, transmitting and receiving. So From sending place, you will have a transmitting antenna. At receiving place, you will have receiving antenna. So, transmitting antenna has a height of 40 meter and the height of the receiving antenna is 30 meter. So, what you are asked to calculate the maximum distance between them for line of sight communication. So, given, what is given here? The radius of the earth is 6.4 into 10 power 6 meter. நீங்கள் earlier sumல பார்த்தீங்க, earlier questionல 6400 kilometer. That is converted to meter means it is 6.4 into 10 power 6 meter. So you can see here the total distance between the transmitting and receiving antenna we have to find out. How will you find? By using the sum of the individual distance of coverage. So D is equal to D1 plus D2. So which is equal to square root of 2R H1 plus square root of 2R H2. H1 is the height of the transmitting antenna, H2 is the height of the receiving antenna. Both the information is given in the question. So that now here if you see root 2R is common out. So you can take common out. So root 2R into bracket la you will have root H1 plus root H2. So இப்போ தெரிஞ்சதெல்லாம் substitute பண்ணோம்னா root 2 value உங்களுக்கு தெரியும் 1.416 and root 2 into 6.4 into 10 power 6, that is radius of the earth, into root of H1 is root 40 and root H2 is root 30. So that this is equal to 16 into 10 power 2 into root 5 into 6.32 plus 5.48. Simplification la we will get this answer. Then the final answer is 42.217 kilometer or 42,217 meter is the idoda answer. So this is how you can calculate the maximum distance transmitting and receiving antenna for line of sight communication. Then next question will go. So explain the three modes of propagation of electromagnetic wave. So what are the three modes of electromagnetic wave propagation? Ground wave propagation or surface wave propagation, and this is nearly 2 kilohertz to 2 megahertz, and sky wave propagation or ionospheric propagation nearly 3 megahertz to 30 megahertz, and space wave propagation nearly 30 megahertz to 400 gigahertz. This is detailed answer. So adanaala each propagation பத்தி நம்ம in detail explain பண்றோம். So let us see the first one, ground wave propagation. So ground wave propagation definition already நம்ம 3 markல பார்த்தோம். அதே தான் we are going to write now. So if the electromagnetic waves transmitted by the transmitter glide over the surface of the earth to reach the receiver, then the propagation is called ground wave propagation. And the corresponding waves are called ground waves or surface waves. In detail பார்த்தோம்னா, here in the ground wave propagation, transmitting and receiving antenna must be close to the earth. This is the main condition. So the size of the antenna plays a major role in deciding the efficiency of the radiation of signals. And during transmission, the electrical signals are attenuated over a distance. Attenuated definition last class la பார்த்தோம். You can see in this picture here how the propagation is done and line of sight, etc. Now next we can see what are the some reasons for attenuation. ஏன் loss of energy இருக்கு, அதோட reasons என்னன்னு பார்த்தோம்னா, increasing distance between the transmitting antenna and receiving antenna, distance increase ஆகிறதுனால, so loss of energy will be there. Then absorption of energy by the earth, tilting of the wave. So these are the reasons why the attenuation is occurring. Now when we see where are all these ground waves are used, ground wave propagation is used. If you see, it is in local broadcasting, radio navigation, for ship-to-ship communication, ship-to-shore communication and mobile communication. இதே நீங்கள் 3 மார்க்கில் பார்த்தீங்க. So 3 மார்க் படித்தா 5 மார்க் கூட you can write it. So sky, next we will see the second mode of propagation in detail, that is sky wave propagation. So the mode of propagation in which the electromagnetic waves radiated from an antenna directed upwards at large angles gets reflected by the ionosphere back to Earth is called skywave propagation or ionospheric propagation. So you can see extremely long distance communication is possible as the radio waves can undergo multiple reflection between the Earth and the ionosphere. So you can continue the explanation with some more points because it's a 5 mark. So that the phenomena of bending the radio waves back to Earth is due to total internal reflection. So in the reason nala idu nadakuduna total internal reflection. So this is the reason why the electromagnetic waves are transmitted at a critical angle to ensure that the waves undergo total reflection and reaches the ground without escaping into space. So the shortest distance between the transmitter and the point of reception of the sky wave along the surface is called as skip distance. There is a zone in between where there is no reception of electromagnetic waves, neither ground nor sky, called as skip zone or skip area. So இப்போ பார்த்திருக்கீங்க இதில் skip zone, skip distance, definitions, அப்புறம் definition of this propagation, all that you learnt in your 3 mark, so that you can combine and write it as a detail. So அடுத்த mode of propagation பார்த்தோம்னா it is a space wave propagation. So about this, it is the process of sending and receiving information signal through space is called space wave communication. And what frequency range is used? The electromagnetic waves of very high frequencies above 30 megahertz are called as space waves. And these waves travel in a straight line from transmitter to the receiver. Hence, it is used for a line of sight communication. It as an abbreviation LOS. Next, for high frequencies, the transmission towers must be high enough so that the transmitted and received signals, direct waves, will not encounter the curvature of the earth, and hence they travel with less attenuation and loss of signal strength. Certain waves reach the receiver after getting reflected from the ground. The communication systems like television broadcast, satellite communication, and radar are based on space wave propagation. The range or distance of coverage of the propagation depends on the height h of the antenna given by the equation h equal to root of 2rh, where r is the radius of the earth and h is the height of the antenna. So இப்போ பார்த்தீங்க நீங்கள் வந்து 3 மார்க்கில் இதை எல்லா கொஸ்டின்ஸுமே கவர் பண்ணியிருக்கோம். ஸோ இதையே வந்து கம்பைன் பண்ணி ஒரு 5 மார்க்காக எழுதலாம். நெக்ஸ்ட் வில் கோ டு சேட்டிலைட் கம்யூனிகேஷன். So satellite communication picture you can see here. Now satellite communication, how it takes place. So the satellite communication is a mode of communication of signal between the transmitter and receiver via satellite. So the message signal from the earth station is transmitted to the satellite on board via an uplink, and the uplink frequency, if you see, it is 6 gigahertz. That is amplified by a transponder and then retransmitted to another earth station via a downlink, and the frequency is 4 gigahertz. So the high frequency radio wave signals travel in a straight line, that is line of sight, may come across tall buildings or mountains or even encounter the curvature of the earth. So a communication satellite relays and amplifies such radio signals via transponder to reach the distance and far off places using uplink and downlink frequency. It is also called as radio repeater in sky. So now what are the application of this satellite communication? If we see, we can know about the weather and we can send the signals from one place to another. So that is weather satellites. So weather satellites, what it does? So they are used to monitor the weather and climate of Earth. By measuring cloud mass These satellites enable us to predict rain and dangerous storms like hurricanes, cyclone, etc. Now, the same thing can be used as for communication purpose. So, how it is used if you see, the satellite communication is used to transmit television, radio, internet signals, etc. So, multiple satellites are used for long distances. Next satellite is navigation satellite. So, where they are used? So, these are employed to determine the geographic location of ships, aircraft or any other object. So, satellite communication patti paathom. Next we will see about radar communication. So, we have to see the next question. Explain the function of radar, give its application. So, what is radar you know? Radar stands for radio detection and ranging system. It is one of the important application of communication system and is mainly used to sense, detect and locate distant objects like aircraft, ships, spacecraft, etc. The angle, range or velocity of the objects that are invisible to the human eye can be determined. Radar uses what? They use electromagnetic waves for communication. The electromagnetic signal is initially radiated into space by an antenna in all directions. So, when the signal strikes the targeted object, it gets reflected and re-radiated in many directions, so that this reflected echo signal is received by the radar antenna, which in turn is delivered to the receiver. Then it is processed and amplified to determine the geographical statistics of the object. The range is determined by calculating the time taken by the signal to travel from radar to the target and back. So, applications of radar pathona, in military it is used for locating and detecting the target. It is used in navigation systems such as shipborne, surface search, air search and weapons guidance systems. To measure precipitation rate and wind speed in meteorological observations, radars are used. Also, it is employed to locate and rescue people in emergency situations. Idella uses of radar. Next, we have seen radar communication. Next, we will go to fiber optic communication. So, this fiber optic communication also is a very important communication which we are using in many fields. So, fiber optic communication is gaining popularity among the various transmission media. How will you justify this? This is the question. So, what answer you can write? So, what is first of all fiber optic communication? You have to say. The method of transmitting information from one place to another in terms of light pulses through an optical fiber is called fiber optic communication. It is the process of replacing wire transmission in communication systems. So, what is the frequency if you see? Light has very high frequency, 400 THz to 790 THz, so than microwave radio systems. You can see in the picture the optical fiber. And what it is made up of, the optical fiber. The fibers are made up of silica glass or silicon dioxide, which is highly abundant on earth. Now it has been replaced with materials such as chalcogenide glasses, fluoroaluminate crystalline materials, because they provide larger infrared wavelength and better transmission capability. As fibers are not electrically conductive, it is preferred in places where multiple channels are to be laid and isolation is required from electrical and electromagnetic interference. Now, we have seen about optical fiber and what it is made up of. Now, let us see where are all we use this optical fiber. So, the optical fiber system has a number of applications, namely international communication, intercity communication, data links, plant and traffic control and defense applications. So, applications of optical fiber communication we have seen. Now let us go to merits. So what are the merits of optical fiber? Fiber cables are very thin. They are very less weight when you compare with copper. The system has much larger bandwidth. So larger bandwidth enna information carrying will be very large. So it can carry large information. And fiber optic system is immune to electrical interferences. Fiber optic cables are cheaper than copper cables. So these are all the merits of optical fiber communication. Next we will see what are the demerits. Not only it has got the merit, it has also got demerits. So let us see what is that. So fiber optic cables are more fragile when compared to copper wires. It is an expensive technology, very costly. But if you see, the recent developments in optical communication provide the data speed at the rate of 25 Gbps. Next we will see what is mobile communication. Mobile communication is used to communicate with others in different locations without the use of any physical connection like wires or cable. It allows the transmission to wider range of area. Regardless of location like house or office, it enables the people to communicate with each other. It provides communication access to remote areas. You can see in this picture how the mobile communication is done. And you know, all of you are using mobiles, so you know more about it. So it provides the facility of roaming, that is, the user may move from one place to another without the need of compromising on the communication. So the maintenance and cost of installation of this communication network also cheap. So applications of mobile communication pathona, it is used for personal communication, and cellular phones offer voice and data connectivity with high speed. Transmission of news across the globe is done within a few seconds. Using Internet of Things, IoT is made possible to control various devices from a single device. Example, home automation using a mobile phone. And also it enables smart classroom, online availability of notes, monitoring student activities, etc. in the field of education, which you are using it now. So நீங்கள் இந்த 5 marks எல்லாம் பார்த்தீங்க. நீங்கள் 1 markக்கு ஸ்பெஷலாக you need not do any preparation. நீங்கள் என்ன பண்ணலான்னா lesson as such give one reading, 2 mark, 3 mark, 5 mark எல்லாம் நீங்கள் ப்ரிப்பேர் பண்ணாலே 1 mark உங்களுக்கு ஈஸியாக நீங்கள் ஸ்கோர் பண்ணலாம். All the best.